So in the last video I showed you how you can replace the library libusb, and hopefully you've tried that if you're following along and you've actually just recompiled the library just as is without actually making any changes and then copied over, making sure your Megatouch still works. Well, now we are going to go ahead and figure out what we have to override in that library. We're gonna end up altering that library, and we have to figure out what we need to alter. So again, we go to the key manager, and there's a couple things we know we're gonna alter. It's got to read the serial number from the key. We're gonna have to override that. There is actually a check whether there's actually a key even inserted, like physically inserted. Is the security key detected? We have to override that. And then we'll have to override the functions that read the data in. But we are gonna start with just messing around with the libusb library just to make sure we can start seeing things and editing things. And we are going to first, I believe, well, we'll see what we're first going to do. First, we're going to do is just add some logging into that file so we know it's actually doing stuff. Okay, so key manager. One of the first things it does is it gets this USB IO instance and gets this key family code. Okay, and that's actually part of the built-in serial number. Okay, so we click on get family code, very short, basically just does this read USB key ID and the local 10. Local 10 is going to be, I can tell you right now, local 10 is going to be a car 8 probably, maybe more, maybe car 9, because I don't know, but it's going to be 8 or 9 bytes more than likely, unless they store the data differently as ASCII, then it's going to be like 16 bytes. But anyway, it is basically, this is going to be the key ID. Oops, I made it. I changed the name to car 8. The name is going to be key ID, and that is going to be a car. We'll just say 8. I'm pretty sure it's a car 8. Yeah. So, yep, that looks correct. UVAR to, yep, and this is going to be the family code. I can just tell you right now what that's doing. It's just grabbing the low byte off of the key ID. So, because that's XOR, or I'm sorry, that's ANDing with that's 1 byte of ANDing, and this is the lowest byte, or the lowest part of the key ID. So, great. So, but anyway, we need to know what this USB key ID is. So, USB key ID is going to call command request, which is going to call read USB memory. All right. Well, we have to figure that out. We have to figure out this command request and this read USB memory. Okay, but they both are end up calling. You can see this libusb control transfer. This is part of the libusb library, and with libusb, if we just do, you can read the documentation online for libusb. It's on that website. So we're just going to search for libusb calls, and you'll notice if you look down, there's a libusb init. And before you do anything with the libusb library, you have to call this init. It's the first thing you're going to do. And then there's also a close at the end, libusb close. So I think the first thing we're going to do is actually alter this library to open a file for us, and then from that file, just log that it has been opened successfully. It's been called successfully, and then we'll probably start to try to figure out what all this stuff is doing. We'll probably start the other ones that I was looking at, the lib control transfer, we'll probably just start logging that and seeing what's going on. And eventually what I think we're going to find is that there's just going to be a certain couple reads, certain memory addresses that we're going to see, and we can just alter the behavior of this program so when we see it request that memory address, that we do what we want to do, and we actually just bypass the whole thing. Okay? So, in that case, let's go ahead and edit that. Let's go ahead and put those changes in. So, the lib, if we go back to my CentOS machine that I'm developing it on, we're going to go to libusb, and the directory of the source code is actually also called libusb. Okay, so we're in my directory libusb 1023 libusb, and the way I found where libusb init is, I just did grep libusb init star, and it told me what files it sees it in. Actually, I should probably just done grep libusb star. I'm sorry, grep. I think minus, was it H or L that tells you just the file names? Nope, that's not it. Yeah, those are the files that it's in. So I just looked through them until I found them, and I found that it's in core.c and libusb init. And there it is. So what I did is I created, first thing I did is in the global variables, and if you don't know C, this may not make a lot of sense to you, but I can't teach you C. There's plenty of videos on C. Is actually, I think, one of the easiest languages. It just has a painful when things go wrong, they're very painful. Whereas a lot of languages seem a lot more complicated to use, but they're easier. Not easier. I think they're a pain. Like, I hate Java and all these high-level languages. I like C because it's very, very simple. There's like 30-some keywords, and everything is very straightforward. It's just that you do have to know what's going on, because it's easy to run into a wall and blow up your whole car, where your car being your project or your programming. Anyway, I digress. So anyway, the point is I added a global variable here. I just put /bb, that's a comment. I said debug file pointer, debug file equals null. That means that's creating a special file object, basically. It's not actually an object because C doesn't have objects, but let's just pretend it's an object. And I set the value to null. Okay. And then in the libusb init function, after it successfully completes, so I go down and I look to see what it's doing, and the first time it runs, when it's never been edited before, it's never been called before, it will get down to here, and this is what I added. If the debug file is null, which is set by default, open the file. So if not debug file, so if the debug file is null, then do this code. Open file name, and this just means this is called write plus. So it's gonna let me write and append to it, and except it already exists, that is, it will just append to it, and then it's going to print to the file that the program libusb, or the function libusb init, has been called successfully. Then it's going to do this, what's called flushing, because I'm using the buffered IO stream, which is easier to do things with than using the raw disk IO or the raw system calls. If you looked at my 2011 Force video, we actually hacked in the code that does the raw code calls. But in this case, I'm going to, because I'm just writing in C, it's very easy just to do this. Anyway, the point is that flush is going to immediately write these lines. If you don't flush it, you may not see any output in the log file until you have so much data written to it, and that can be confusing. So anyway, and that's it. So it's just going to create a global variable, and then if that global variable is set to null, it's going to open this file and then set that global variable now no longer to null. It's going to be the value of this file stream, debug files. It's called a stream. And then it's going to write a log file. So we're going to compile it. Clear. Make clean. Make sure it actually works. Copy it over, and then make sure we actually see. We'll reboot it and make sure that that file comes up and it has that in there. So go ahead and do that. So again, since I had rebooted my machine since I did the last video, I went ahead and SSH'd into it, did a mount -o remount with a RW option / and I'm just going to go ahead and now copy the file over. So cd to libs, the file, the actual, oops, the actual direct, you don't have to do that make install like I did in the last video. The library just is within the libusb directory in a .libs file after you compile it. So I'm just going to do scp root at 10.0.1.14. Oops, nope, I got to give the file name first. And then I'm going to copy it to user lib. It should work. We'll go to the machine and reboot it. Reboot. And it should come up, and hopefully we'll have a log file that has a line that says libusb in it called successfully when we're done. So this will take a couple minutes for my machine to reboot, and as soon as it comes up, I'm just going to pause the video and I'll just resume when we're done, when it's done rebooting. So my Ion has finished rebooting, and I can see that it is in the Megatouch game thing, so everything again is still working. So I'm going to SSH down over there, and we stored the file in temp. Do an ls, I called it USB-IO log, so we'll just do a cat USB-IO log. And you can see it actually logged that USB in it was called successfully. That's great, that's what we wanted. Now, oh, this video is almost 15 minutes long already. So I guess we'll try that out yourself, and in the next video we're going to actually start figuring out what other functions to hook and start looking at the data that we're interested in and making sure the data comes in and out. We'll probably try to, I don't know what we're going to do. Should we first look at the security key and trying to override that, or the serial number? I'm not sure. This is security key detected or the reading of the serial number. I think the reading of the serial number will be more fun, but is security key detected is more actually immediately useful, because we can immediately see what happens. We'll take the security key out, boot it, see what happens, and then we should get farther once we override that. So I don't know. We'll figure it out in the next episode. Thanks for watching.